Hi, so this is Priyam from EB32 E20479, second year, fourth semester. I'm making this video as a presentation on cryptography for my final assignment of CN. So what is cryptography actually? So let's start the presentation and see cryptography, what it is and why it is in demand nowadays. So it's a very fond of topic. Cryptography. We know about stuffs like Bitcoin, cryptocurrency. They are really popular these days. But do we know the underlying technology behind them? Like what's actually going and how it is making like the guarantees that it is super secure and it won't ever change. How it happens? This is how it happens using cryptography, like the base of cryptocurrencies. And so we know the underlying technology, but no. So let's know about cryptography today. So today's agenda, what are we going to discuss for today? So it will be an introductory session on cryptography, while we will also about cryptography and its purposes, the types of attacks in cryptography and the cryptography. So here's the introduction. Cryptography is the practice of secure communication in the presence of third parties. It's mathematical science that uses mathematical algorithms to code and decode data. So what does this mean? So cryptography, like in the recent days, like our main way of communication is data, like sharing data, and most of our data is public. Like when you send from your phone to your friends, it goes like in public through a public line are traveling. So anyone can capture that and see what you. That could be a breach in privacy. But cryptography somehow that keep whatever you send to your friend, only your friend can open it. When you see in WhatsApp nowadays, they show end-to-end encrypted. It has something to do with in cryptography only. And cryptography is not a computer science phenomenon, it's a mathematical way. The computer basically maths implemented. So cryptography is actually just math algorithms to encode and decode data. Now, cryptography is used in variety of applications, including emails, file sharing, secure communication in Bitcoin and cryptocurrency. The underlying technology behind blockchain and cryptocurrency is cryptography. So this has been the introduction. Now let's move forward. So where can I use it? Okay, so this is a very interesting topic. Where can actually cryptography be used? So it could be used for secure communication. Like I just told, when you send a message or an email or you transfer a file to your friend or like someone like you want to send, suppose that you are working in a company and it's a super secret file and you have to send it to your boss. You don't want anyone else to see that file. So cryptography enables it that only your boss will be able to open that file and no one else will. It happens seamlessly nowadays, but there's a lot of underlying technology that's helping us to maintain this secrecy and security. Now, authentication. If you have to authenticate, like someone sending a message or accessing a system, like when you log in, it somehow uses cryptography and verifies that you are the person that's being logging in, like you are the right person. This is for authentication, non-repudiation, to prove that a message has been sent by a specific person and cannot be denied that by person later. Like suppose someone sends a message and it later comes in a legal case. See, this message has been sent and they try to deny it. So this non-repudiation, like they makes it clear that no one can deny it. Because on the first end, only that person can send that message. So it becomes a two pro goal that only if that person can send, then only that person can receive. The person receives, so they cannot deny it. Cryptography is involved in this and data integrity to ensure that the data is not tampered with or corrupted. So what does this mean? Not corrupted or in how do they ensure? So we later learn that cryptography has this hash function, and when you put a data, like suppose you have a apple, there are a lot of apples in the world, but you have a specific apple, Okay, and if you put that apple into a machine, a let string is generated, string of characters is generated, and only if you put that apple into the machine, only that string will then only be generated. So in first, when you send your data, you put the string like the apple and you get that string. Now, if someone tries to catch your data or like tamper your data, like instead of your apple, they place another apple, that string, another string will be generated, but then the string will be matched and they can see that these two are the same. So we can clearly see how data integrity works. This is a clear case in how blockchain actually works. Like with the hash function, if someone tries to include it in the chain and it does not, what actually happens with Bitcoin blockchain is that everyone has a copy of a ledger. Just suppose that you have a register and everyone has the same register and everyone notes down what is happening where. When a transaction happens, like I send someone 1 Bitcoin, then everyone will have to note down that he sent a Bitcoin to them. So now if I want to make a change, like I just inside my ledger, I change fraudulently that I sent to him even though I have not sent. Now everyone won't, now this change will only be in my ledger and not in anyone else's ledger. This means that I have tampered with it and this data is incorrect. So hence this transaction will be denied and my ledger will be turned back to original. Now what is the structure of like cryptography? So you can see this is my key, Priyam's private key, and this is my message. And this is a random session key and like my friend Raj's private key. So if I make a public key crypto, so with public key crypto, it directly sends you a digital signature. This is the goal. What it creates, and actually to send a message, it creates an envelope with digital signature so that they know that only you have sent that message and no one else. And then they send it. Like if it's my message, it will create a hash function out of it, and then it will be sent. Like if they are using the secret key crypto, then it would be used to encrypt message, and the random person's key will be used, public key will be used to encrypted encrypted session key. All together, this everything of this combines to make a digital envelope, which is sent to Raj, my friend, and it is then like opened later on in the stage and stuff is verified. Like my digital signature is verified and it knows I have sent the message. Suppose you send a WhatsApp text to your friend. How does WhatsApp know that only like when your friend receives that only you have sent it? For it with a digital signature, and that's all. Like for it, like stuff else stuff is also going on behind the scene, but this is basically the general idea. Now types of cryptography. There are four actually, like there are a lot, but these four are the main. Symmetric key cryptography. So in this, so there are two things: encrypting data and decrypting data. Encrypting data means that you changing the data into some like random text, not random, a coded string which makes no sense. And decryption means you are taking that string and turning it back into the original data. So for key cryptography, what you do is you turn the both are same. Like the one that turns the encrypts and decrypts the data, both of the stuff is done by the same key. Key can be called as a function. Okay. Now asymmetric key cryptography. What is asymmetric key cryptography? In this, the encrypting key is different from the decrypting key. And what is public key cryptography? Now this is really similar to asymmetric key cryptography, but in this, when the encrypting key is made public, like everyone will know what the encryption key is, but the decrypting key is kept private, so no one will know how to decrypt it, even if they know how to make like a string, don't know how to turn it back into the original text. And what is hash? hash-based cryptography, like I talked earlier, hash-based cryptography makes a specific string out of a like the Apple analogy that I gave. This is actually using the hash-based technology. It gives out a specific string which can later be verified on later stages. So these are the types of cryptography. Let's move on. Now, what are the attacks of cryptography? So let's see what are these. Like attacks of cryptography means how does it work? Like how can they be attacked? Plain text attack. This happens when the attacker has the access to both the encrypted and the corresponding plain text. Now, let's say you have a message, you encrypted it, and now this attacker has this encrypted message also and the original message also. Now they will find a way to decrypt it, and using various techniques they might be able to find how are you encoding it, and then they'll use that on other messages. Now what is chosen? Now let's see the second one, chosen plain text attack. This is similar to a known plaintext attack, but in this case, the attacker gets to choose what plaintext is encrypted, and this can be used to narrow down the possible keys. In this, if you have ever played any basic encryption games, like if you are turning letter S into J, E, and first occurrence you are turning into JE and second occurrence you are not. So the hacker on the first try won't know if they are using the plain text attack. But if they get to decide what all in plain text is content encrypted, then they can do various tries and know for the best case what is actually doing what. Now let's see, there are two more types of attacks. Ciphertext attack, this is a really popular one. In this case, the attacker gets to choose what ciphertext is encrypted. This can be used to figure out information about the key. In this, the attacker gets to choose, like I guess this is self-evident and I don't have to explain this in much in this. Now, what is man in the middle? This is where the attacker encrypts the message between two parties and tries to decrypt them. If successful, the attacker can agree. Now let's see intercepts, not encrypt, sorry. There's a mistake there. So the attacker is you are sending a message to your friend, and in between the attacker like captures your message and tries to decrypt it. Just to find out what the actual message is. If he is able to find out, he'll get the key, he'll know the key, and then you'll be able to read all the messages. As intercepting messages is really easy, but decrypting them is not. So what cryptography is a critical tool for keeping information safe. Understanding how it works, we can better protect our data from being accessed by unauthorized individuals. Like within the previous PPT, I guess it is self-evident enough how powerful is cryptography and how it will be used. And it is being used nowadays to make stuff more secure for us. Thank you. This has been Prem Srivastav, and I would like to take a leave now. I hope this cryptography presentation was decent enough and were able to understand what I was trying to explain. Thanks.